morning, students. Our next chapter is binomial theorem. Take the word binomial. Here, bi means two and nominal means terms. Okay. Meaning of binomial is two terms. Then what is the meaning of binomial theorem? Binomial theorem is nothing but theorem on two-term expressions. We studied the formulas for a plus b whole square or a plus b whole cube, okay, in our lower classes, right? See, here two terms are there. What are the terms? A and b. Here also two terms, a and b, power 2 power 3 is there. We know how to expand this. Suppose if you want to find the value of x plus 2 to the power 10 or x minus 3 to the power 20, okay, whenever these types of questions arises, that time to expand this expansion we are using binomial theorem. Or we know 99 to the power 2 we can calculate easily. Or suppose 99 to the power 10 is given, find the value of 99 to the power 10 without using calculator. To find the values we are using binomial theorem. Okay, if we apply the binomial theorem, it's little easy to calculate the value of 99 to the power 10 likewise. Okay, these are some applications of binomial theorems. Remember, bi means two, nomial means term. Binomial theorem is nothing but theorem on two terms expressions. Okay, now see, consider a plus b. Here a and b are two terms. We know a plus b to the power 0. Any number to the power 0 equal to 1, where a plus b is not equal to 0. Why? 0 to the power 0 is intermediate value, right? That's why you need to take a plus b is not equal to 0. Then any number to the power 0 equal to 1. Then I'm taking a plus b to the power 1. Its value is equal to a plus b. And next is a plus b whole square is equal to a square plus 2ab plus b square. We know the formula, right? Then write the formula for a plus b whole cube. We know its value is equal to a cube plus 2a square b plus 2ab square plus b cube, right? A cube plus b cube plus 2a square b plus 2ab square. It's a formula for a plus b whole cube. Now see, a plus b to the power 4 or a plus b to the power 5 is given. It's little difficult to remember the formula, but using binomial expansion you can write the formula easily. Now consider these four expressions. Here see power. Okay, here in binomial theorem, power of the expression we called it as index. Okay, index of the expression. Now see here, what is the index? In the first case, index equal to 0, second case index equal to 1, third case index equal to 2, and the fourth case index is equal to 3. Okay, now see here, index 0, and how many terms are there in the right hand side? It's equal to 1. Now see, index 1 here, then how many terms are there in the right hand side? That is equal to 2. Index 2, how many terms are there? See, 1, 2, 3 terms are there. Index 3 means how many terms? 1, 2, 3, 4 terms are there, right? So, by this observation, we can write it as the total number of terms in the expansion is 1 more than the index. Clear? See, here index 0 is there. That means how many terms you are getting in the right hand side? That means terms in the expansion. expanding, right? In the right hand side, expansion of the given expression is there. See, you are getting one term. Here see index 1. That means see here in the right hand side expansion has two terms, a plus b. You can see two terms. Here see index is equal to 2. How many terms are there? 1, 2, 3. Okay. Index 3 is there. Then how many terms you can see? 1, 2, 3, 4 terms are there. Okay. That is the first observation. Okay. Total number of terms in the expansion is 1 more than the index. Then a plus b to the power 4 means how many terms you are getting? 5 terms, right? Why? Because total terms in the expansion is 1 more than the index. 1, 2, 3, 4, 5 terms you will get. Remember, very important observation. Index 1 means number of terms equal to 2. Index 5 means number of terms is equal to 6. Okay, or in the expansion 6 terms are there means how, what is the index? Index is equal to 5. Okay, just remember the total number of terms in the expansion is 1 more than the index. Okay, now say here a plus b to the power 1 is there. Here a, I'll write it as a into b to the power 0 plus b into a to the power 0. Yes or no? In the first expansion, see a into there is no b. No b means b to the power 0 equal to 1. A into 1 is a. Plus in the second expression there is no a. No a means a to the power 0 into b. 1 into b is b. Now observe this expansion. See here a to the power 1 is there. While coming to the second expansion, that means while moving to the right side, a to the power c 0 is there. Here see b to the power 0 is there. While moving to the right hand side, you will get b to the power 1. Or consider this expansion a square into b to the power 0, right? No b means b to the power 0 plus 2ab plus a to the power 0 into b square. Okay, I am rewriting that expansion. Now see, first a to the power 2. Then here you can see a to the power 1. Then a to the power 0. What is your observation? As we move from left side to right side in the expansion, a to the power decreases. That means power of the first term decreases. What about power of the second term? See here, b to the power 0, b to the power 1 and b to the power 2. Clear? As we move from left side to right side in the expansion, here see first quantity, that means a here, right? Power of the first term increases by 1. Yes or no? 2. Power of the first term decreases by 1. Why? First to 2, next to 2 minus 1, that is 1. Then 1 minus 1, it's equal to 0. You can observe clear difference. Then power of the second term, that means second quantity, increase by 1. Yes or no? See 0, next to 1, next to 2. Here you can see difference 1, right? Okay. Or consider the third expansion. See, you can write it as a cube into b to the power 0 plus 2a square b plus 2ab square plus a to the power 0 into b cube. Now again check. See, first check the first quantity. What is the power? 3. A to the power 3, a to the power 2, a to the power 1, a to the power 0. As we move from left side to right side in the expansion of the two terms, power of the first quantity decrease by 1. What about power of the second quantity here? B, right? See, b to the power 0, b to the power 1, b to the power 2 and b to the power 3. Okay, it's a very important observation. That's a second observation. As we move from left side to right side in the expansion, power of the first quantity decrease by 1 and power of the second quantity increase by 1. I'll write it there. Okay, as we move from left to right in the expansion, power of the first quantity decrease by 1 and power of the second quantity increase by 1. Okay, it is our observation. Okay, now see here a plus b to the power 1 is there, index equal to 1 is there. Now check what is power of a. Now consider the first term in the expansion, that is ab. Add the powers 1 plus 0, it is equal to index. Take the second term a to the power 0 into b. Add the terms, what you will get 0 plus 1. Okay, add the powers of the second term 0 plus 1, it is value is equal to 1 only. Now take the second expansion, index equal to 2. Now see, consider the first term, that is a square into b to the power 0. Add the powers of the first term in the expansion, 2 plus 0, it's equal to index. Consider the second term, that is 2ab. Add the powers of the terms 1 plus 1, right? A to the power 1, b to the power 1 is there. 1 plus 1. Again, it's equal to index. Then see, a to the power 0 into b square is there. Okay. Add the powers. See here, 0 plus 2, it's equal to 2. Or here see, 3 plus 0, that is equal to index 3. 2 plus 1, here power see, 2 plus 1, it's equal to index 3. 1 plus 2, it's equal to index 3. 0 plus 3, it is again equal to index 3. By this, you can say that in each term of the expansion, okay, you are considering each term of the given expansion, the sum of the indices of A and B. That means first quantity and the second quantity is same and is equal to index of A plus B. Okay, you can observe, right, in each term if you add their sum remains same. See, 3 plus 0, indices is nothing but powers. Okay, 3 plus 0, it's equal to 3. 2 plus 1 equal to 3. 1 plus 2 equal to 3. 0 plus 3, it's equal to again 3. See, throughout each terms, their sum of the indices or sum of the powers of the first quantity and second quantity remain same. And moreover, what is our observation? That sum of the indices equal to index, right? See, here 3 you are getting, here 3, here 3, here 3 you are getting. 3 is nothing but index of the given expression, right? So that is the third observation. Okay. Now consider the expressions a plus b to the power 0 equal to 1 and a plus b whole square, or consider a plus b to the power 1 is a plus b whole square, it's equal to a square plus 2ab plus b square, and a plus b whole cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Okay, now see, in this index and here I will write coefficients. Coefficients is nothing but constant terms with the a b. Okay, when index equal to 0, power equal to 0, you are finding only one constant term, that is 1. Okay, when index equal to 1, see, with the a, what's the constant term? We'll get 1. With respect to b, you will get constant term 1. When index equal to 2, okay, we are getting 3 terms, right? First, what's the coefficient? First coefficient is 1. What's the second coefficient? Second coefficient is 2. And what's the third coefficient? Third coefficient equal to 1. When index equal to 3, see, you can see first coefficient that is equal to 1, then second coefficient that is equal to 3, Again, third coefficient you can see 3, and the fourth coefficient that's equal to 1. Okay, now see, when index equal to 4, by observing this you can write the coefficients. Okay, that means constant term with respect to AB. See, first you need to write 1 0, then same 1 here and here you need to write a plus b, you'll get 1 and 1. To write a plus b whole square coefficients, first write this 1, then add 1 plus 1 2, then write the 1. See, first write this 1 here, then add 1 plus 1, that is 2, then right hand side 1 you need to write here. To write coefficients of a plus b whole cube, first write, see, 1 to 1 is there, right? First write this 1 here, then add 1 plus 2, it is equal to 3, 2 plus 1, it's equal to 3, then remaining 1. Now see, I'm writing coefficients of the expression 4 with index 4. First you need to write 1, this 1, then add 1 plus 3, it's equal to 4. Then 3 plus 3, it's equal to 6. Then 3 plus 1, it's equal to 4. Then 1, remaining 1 you need to write. Okay, suppose index equal to 5 is there. Okay, then see, you can write it as 1, first you need to write this 1, then 1 plus 4, it's equal to 5. 4 plus 6, it is equal to 10. Then 6 plus 4, it is equal to 10. Then 4 plus 1, it's equal to 5. Then you need to write the remaining 1. Okay, now see, I'm writing expression for a plus b to the power 4. A plus b to the power 4 is equal to, remember that 3 conditions. First condition is, if index equal to n, then number of terms is equal to n plus 1. Okay, that means total number of terms in the expansion is 1 more than the index. That means here index 4 means how many terms you need to get? 5 terms in the expansion. Second condition is, as we move from left side to right side, power of the first quantity decrease by 1, power of the second quantity increase by 1. Then third observation is, sum of the indices in expansion, that means in each terms of the expansion, sum of the indices are equal and it's equal to index. So first see, what you have to take, coefficient 1. 1 into a to the power 4 plus, now see, here b to the power is 0, right? I'm not going to write that one. Then consider the coefficient. What's the coefficient? 4 into power of the first term decrease by 1, a to the power 3, and power of the second term increase by 1. Next plus, here you can see 6, power of the a decrease by 1, power of b increase by 1. Next you can see the constant term, that is 4 into power of a increase by 1, power of a decrease by 1, you'll get a, power of b increase by 1. Then plus, here you can see 1, okay, 1 into power of a decrease by 1, that means a to the power 0, it's equal to 1, and b to the power 4. Okay, see, 1 2 3 4 5 terms are there in the expansion. First condition holds. See, a to the power 4, a to the power 3, a to the power 2, a to the power 1, a to the power 0, power of a first quantity decrease by 1. See, b to the power 0, b to the power 1, b to the power 2, b to the power 3, b to the power 4, power of b increase by 1. Okay, now see, here 4 plus 0, b to the power 0, right? 4 plus 0, 4, 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, 4 plus 0, it's equal to 4. See, in each term, sum of the indices remain same, and the next data, see, it's equal to index, right? 4 plus 0, index, 3 plus 1, 4, index, 2 plus 2, 4, index, 1 plus 3, 4, index, 4 plus 0, it's again equal to index. Now try to write the expansion for a plus b to the power 5. A plus b to the power 5 is equal to, see, first 1, right? That means a to the power 5 into b to the power 0 plus, see, 5 into a to the power decrease by 1. So a to the power 4, b to the power increase by 1. You will get b to the power 1. Okay, next see coefficient, you can see 10 into a to the power decrease by 1 and b to the power increase by 1. Okay, while writing, just remember, if you add power of a plus b, you need to get index 5. Okay, next again you can see the coefficient 10 into a to the power decrease by 1 and b to the power increase by 1, a square into b cube. Next you can see 5. Okay, 5 into a to the power decrease by 1, b to the power increase by 1, and last 1 into a to the power decrease by 1 means a to the power 0 into b to the power 5. 1, 2, 3, 4, 5, 6. Okay, index 5 means total number of terms is 1 more than the index. So you will get 6 terms. Okay, and see again this expression holds for all three conditions. See, power of a increase by power of a decrease by 1 as we move from left side to right side, and power of b increase by 1 again as we move from left side to right side. Then see index 5 means total number of terms 5 plus 1 it's equal to 6, as well as sum of indices same and it's equal to index. Okay, it's a main observation. Okay, consider this coefficient. You can write this coefficient using a combination. Okay, see here index 0 is there, right? So we can write it is equal to 0 c 0. Okay, we know nc 0 value equal to 1, right? So you will get it's equal to 1 itself. Okay, now see 1 1 is there, you can write it as 1c0 and 1c1. Why? Because 1c0 value is 1, 1c1 value also equal to 1. Just check the values in combinations. Now here see 1 to 1 is there, right? Index 2 you can take it as 2c0, 2c1 and 2c2. Okay, 2c0, what's the value of 2c0? 2c0 value is 1, 2c1 value is 2, 2c2 ncn value again it's equal to 1. Okay, 1c0 is 1, 1c1 also equal to 1, 2c0 value equal to 1, 2c1 value is 2, 2c2 value equal to 1. Then see here index 3 is there, right? So you need to take n value equal to 3. You can write it as 3c0, 3c1, 3c2 and 3c3. Okay, 3c0 value is 1, 3c1 value is 3, 3c2 value is 3, 3c3 value equal to 1. Okay, then index 4 means you need to start from 4. You can write it as 4c0, 4c1, 4c2, 4c3 and 4c4. Okay, now see 4c0 value is 1, 4c1 4, 4c2 6, 4c3 4, 4c4 value equal to again 1. Okay, values remain same, but here we are using combinations. Okay, in our next concept we are using combination notations. Okay, otherwise it's difficult to remember the values, right? That's why we are using combination notations. Now observe this coefficients looks like a triangle, right? Yes or no? If you observe clearly, see this arrangement looks like triangle, or you could take the combination arrangement also. See this arrangement is looks like a combination. We called it as Pascal's triangle. Okay, the mathematician Pascal introduced this method. We called it as Pascal's triangle. Okay, Pascal's triangle is nothing but arrangement of coefficients of the binomial expressions. Okay, that looks like a triangle, so we called it as Pascal's triangles. Okay, it's very important to remember Pascal's triangles in combination notation for write higher expressions. Okay, just remember Pascal's triangles is nothing but the arrangement of coefficients of the binomial expressions. Okay, that looks like a triangle, so we call it as Pascal's triangle. Pascal's because it's the name of the mathematician who introduced this method. Okay.